Okay, in this video we're going to go through section 5.4, and this is the last section in the identities. So just a little bit more practice with identities. Nothing really too new, but just some more identities that we can use. So the double angle identities. If you have sine of 2 times an angle where the angle is u, I tend to like to use theta instead. So I would have wrote this as, I'll write it up here, sine of 2 theta is equal to 2 sine theta cosine theta. So it doesn't matter what u is, whether it's theta or alpha or beta. But if you have sine of 2 times an angle, it simplifies down to that identity. If you have cosine of 2 times an angle, there's 3 different identities for that. So you have to pick the one that is the easiest to use in whatever problem you're in. So it's either cosine squared u minus sine squared u. Be careful, that's not a plus. Or it's 2 cosine squared u minus 1, or 1 minus 2 sine squared u. And we'll prove a couple of these in our first couple problems. And then tan of 2 times an angle is 2 tan of the angle over 1 minus tan squared of the angle. Now the power reducing are pretty quick to figure out. Essentially what that means is if you have something squared, like if you have sine squared and you want to get rid of the squared part, or you have cosine squared, we can use one of these identities backwards. So for example, I'm going to take the 2 cosine squared u up there. So I'm going to say cosine of 2u is equal to 2 cosine squared u minus 1. And if I didn't want to have a squared in my identity for some reason, I could rewrite this as cosine of 2u plus 1 is equal to 2 cosine squared u. And then if I divide that by 2, I get the first identity of the power reducing, that cosine squared u is equal to cosine of 2u over 2. Now be careful, you have to write that squared small, because you don't want that squared to start looking like a 2 times an angle. Right? So be very careful that when you're writing these, that you're emphasizing whether it's a squared or whether it's a 2 times the angle. The 2 times the angle should be like the same size as the angle that you wrote. And we could write sine squared of u, if we take this equation here. Oh shoot, I forgot the plus 1 when I copied this over. Cosine 2u plus 1, cosine 2u plus 1. If I do the sine squared of u, I get sine squared of u is going to equal 1 minus cosine of 2u over 2. Right, so if I took this, right, so I show that I did a little proof here on the side. If I take this one here and I say 1 minus sine squared of u is equal to cosine of 2u, and I want to get the sine squared by itself, so I'll subtract 1, and I get negative sine squared of u, that's a squared, equals cosine of 2u minus 1. Oh, there was a 2 here. 1 minus 2 sine squared u equals cosine of 2u. So I have minus 2. So now I'm going to divide by minus 2. And that minus can go into the tops, and you would get sine squared of u is equal to, so the negative is going to switch the 2 signs on the top. If I basically divide both the top and bottom by the negative, I'll get a positive 2 on the bottom, and I'll get 1 minus cosine of 2u on the top. And that's how you get this identity. Okay, so those are the couple new identities in section 5.4. We have power reducing identities, we have double angle identities, and then lastly, we have half angle identities. And so the half angle identities are basically going backwards from the double angle identities. It's sort of looking at, if this was an angle, how would I get the half angle of it? And so these are just a slight extension of the double angle. So instead of it being sine of u, it's sine of 1/2 of u. Okay, and we'll use these in the problem. So let's just do the first couple of problems on this video, and then we'll switch to the next video. So the problems that were assigned is 475, 1 through 35 odd. Prove the identity. Number 1 and 3 are prove the identity using a sum and difference identity. So remember, we have cosine of u plus v, and cosine of u minus v, and sine of u plus v. We have identities for these. So you might want to get your identity sheet out. So we're going to say cosine of 2u, right? and I'm going to make it match this right-hand side. So cosine of 2u is the same as cosine of u plus u, because u plus u is equal to 2u. So I can do algebra inside of those parentheses, right? Now, this is sort of like the sum and difference. This is the cosine of u plus u instead of u plus v. So if we remember, the cosine of u plus v is equal to cosine of u, cosine of v, but in this case v is just another u, minus sine of u, sine of v, but again v is just another u in this case. And so we get cosine squared u minus sine squared u, and that's what we were trying to prove, right? And that just comes down. And essentially what we were doing, plugging in, is cosine of u plus v is equal to cosine of u cosine of v minus sine of u sine of v. But instead of it being a u plus v, it's a u plus u. So we have a u and a u and a u and a u. That's how you do that one. Okay, so now we'll do number 3. We'll do number 3 in blue. So now we want to prove one of the other identities for cosine of 2u. So cosine of 2u can either equal cosine squared minus sine squared, like we saw on the page before, right? So it can either equal this, or this is another one, and there's a third option as well. So we're going to do this again. We're going to rewrite this as cosine of u plus u, because 2u is equal to u plus u. And then we're going to use the sum and difference identity. So we're going to say that's equal to cosine of u, cosine of v, but v is u, minus sine of u, sine of v, but v is u. And so that's going to equal cosine squared u minus sine squared u. So we're back to where we were in the problem above. But I want it to be 1 minus 2 sine squared u. When I'm done with this proof, I want it to equal this side, 1 minus 2 sine squared u. So I'm going to use my Pythagorean identity, and I'm going to say, oh, well, cosine squared is 1 minus sine squared, right? Because don't ever forget, cosine squared u plus sine squared u equals 1. So cosine squared u is 1 minus sine squared u. That's the Pythagorean identity. Most important one, right? So cosine squared is equal to that, and then minus another sine squared u. And so we get 1 minus 2 sine squared u, which is what we were trying to prove. So this is definitely true. Okay?